In this lecture, we will talk about properties of determinants. We will use examples to show that there are three properties, 1, 2, 3, for determinants of a matrix. The example we are going to do right here is a 2 by 2 matrix. But here all the properties apply to 3 by 3, 4 by 4, or n by n matrices. Let's look at this example. We know A is a matrix given like A, B, C, D with square bracket. 2 by 2 means 2 rows, 2 columns. Okay, please remember, owning square matrices means they have the same number of rows. The number of rows equals the number of columns. Owning those square matrices, they have determinants. Otherwise, they don't. Okay. Now, then the determinant of A for a 2 by 2 matrix is denoted by vertical line, which is A times D minus B times C. A times D, this diagonal, minus B times C, this diagonal. Okay, it's always subtraction. Now, let's see what property they have. If we exchange 2 rows or 2 columns, here I did is I exchanged 2 rows. You see, AB, first row, go to the second row. And then the second row goes to the first row. I exchanged 2 rows. Then what's going to happen for the determinant? Okay. So the determinant of B, this matrix, CDAB, then you have a C times B. Okay, C times B right here, minus A times D. Okay, that would be CB minus AD. Okay. Now, if you pour the negative sign out, here, then you'll have a AD minus BC. Because if you pour this negative sign out, then AD comes to be positive. BC was positive. You pour negative sign out, then they will have another negative sign right here. Because when you do the distribution, you have a negative 1 times AD, that's negative AD. Negative 1 times negative BC, that's positive BC. Okay. The reason I'm doing so is because, look, AD minus BC, negative. AD minus BC without negative. That means the determinant for B is just to put the negative in front of this, or put the negative in front of this. Okay, anyway, they are opposite. Okay, if you get A, then you put a negative sign in front of it, you have a determinant for B. Yeah, if you have a determinant for B, you put a negative sign in front of determinant B, you will have it for A. So, here it says that exchange 2 rows, you will have a determinant ABCD. Yeah, this matrix equals the determinant. Here is CDAB, you exchange 2 rows. Exchange those 2 rows. So you put a negative sign in front of it. You see CDAB, it was negative. You put a negative, another negative in front of this, then you have negative, negative, positive. Okay, negative, negative comes to be positive, will be that. So here it says that exchange two rows, change the sign. That's it. Okay, nothing happened, nothing else happened, but sign has to be different. If you do yourself, exchange two columns, you'll end up with the same answer. Sign will be changed. And this one, this property again applies to 3 by 3, 4 by 4, n by n matrices. Okay, remember again, exchange two rows or exchange two columns, the sign will be changed. That's it. So property 1, you may say, change the sign. The rule of change the sign comes from if you exchange two rows or two columns. That's the rule. Okay? Now, we keep moving. We'll have examples later on. Let's do another two properties. After that, we do some examples. Now, one row or column multiplied by a constant. What's the meaning for that? Look, what's the difference between matrix A, A, B, C, D, and C, A, B are the same. Row 1 is the same. But row 2 is different, K, C, K, D. So row 2 has something extra. It has a common factor K here. It was CD. Now there is a K in front of C, the same K in front of D. Let's see what's going to change, how the determinant is going to be changed. Again, A times KD, A times KD minus KC times B. It's always this diagonal minus this diagonal. So what do we have? Pull K out. Then you have AD right here minus BC right here. Okay. So what's the difference then? Previously, for matrix, determinant of matrix A, you have AD minus BC. Now for determinant of C, you have a K in front of it. Okay. So this tells us that if you use K to multiply this AD minus BC, you will have your A. Okay. This was the determinant of A. Right here, clearly. Determinant of A is this one, which is AD minus BC. Okay, which is this one. This was determinant of A. Okay. Now, if you have a K in front of it, then it ends up with the determinant of C. This tells us what? This tells us that the determinant of C, it has K in front of it. Okay? If you pull K out, then this K times the determinant of original determinant AB, CD here, then you will get the determinant of this one. Okay? So basically here it says that if there is a common factor in a row or in a column, you can pull this K out in front of the whole determinant. That's what it says. So here it says the constant can be taken out. So this constant can be taken out. That's a good technique. Okay, if you take the common factor K out, CD will be smaller than previously K times C, k times t. That's the purpose. Make those numbers smaller than before, so it's easy to operate. Okay. Again, here I did on the row. You may do on the column. The same thing will happen. You may try yourself. Okay. So this property again applies to, here I did 2 by 2. It applies to 3 to 3, 4 to 4, 4 by 4, n by n. Okay? So this is the second property. Common factor on one row, can be pulled out. Okay? Remember that. Only on one row or one column, then it can be pulled out to the in front of the whole determinant. Okay. Now, let's look at the property